Hello everyone, welcome back to my YouTube channel Geeky Codes. We are solving SQL 50-day challenge and today is day 10 of this series. The 10th problem in this series is average time of process per machine, and the problem given is problem number 1661 and it says average time of process per machine. In this problem, we have been given a table called activity and it contains 4 columns: machine ID, process ID, activity type and timestamp. The table shows the user activity of for a factory website. Machine ID, process ID and activity type combined is the primary key for this table. Machine ID is the ID of a machine. Process ID is the ID of a process running on the machine with ID, machine ID. Activity type is an enum category of type start and end. Timestamp is a float representing the current time in seconds. Start means the machine starts the process at the given timestamp, and end means the machine ends the process at given timestamp. The start timestamp will always be before the end and timestamp for every machine ID and process ID pair. It is also guaranteed that each machine ID and process ID pair has a start and end timestamp. So there is a factory website that has several machines, each running the same number of processes. Write a solution. We have to write a solution to find the average time each machine takes to complete a process. The time to complete a process is the end timestamp minus the start timestamp. The average time is calculated by the total time to complete every process on the machine divided by the number of processes that were run. And the resulting table should have the machine ID along with the average time as processing time, which should be rounded to 3 decimal places. And we have to return the result in any order. The result format is also given in the following example. As you can see here that our activity table is given something like machine ID, process ID, activity type and timestamp. Machine ID is 0 and start is given at 0.712 and end is 1.520. So for the process ID 0, it takes around 8.08 seconds, and similarly the next process is given for the same machine, and similarly this table has been given, and we have been given the output table. That means machine ID 0 takes 0.894 seconds to complete a process, and machine ID 1 takes 0.995 seconds to complete, and machine ID 2 takes 1.456 seconds on an average to complete a process. So let's try and solve this problem. So we know that processing time for each machine ID and process ID pair is end timestamp minus start timestamp, and average processing time for each machine ID is the sum of all processes time divided by the number of processes. So here we can use group by machine ID along with the conditional aggregation case when or join to achieve this. So let's solve this problem. We will be selecting machine ID, and we will be creating a round average of end underscore time minus start underscore time, and then comma 3 as we will be rounding up our average time up to 3 decimals. So that is why this 3 is here, and then processing time from, and here we are writing a nested query that will select machine ID comma process ID comma max case when activity underscore type equal to end, then timestamp end as end time, and we will also be selecting as end time, and we will be selecting the like max, and then case when activity underscore type is equal to start, then timestamp end as start underscore time from activity table, and group by machine underscore id comma process underscore id, and that we will select as t, and here we will group by machine id, group by machine id. So that is our code, and now let's explain this query. So here we are extracting start and end timestamp for each machine id and process id. Here we are selecting max when activity type is end, then we are selecting timestamp as end time, and when activity type is start, then we are selecting timestamp as start time, and from this activity, and the data is grouped by machine id and process id. Here we are using max case when activity type is equal to start to get the start time, and max activity type is equal to end the timestamp end as end time to extract the end time, and we group by machine id and process id to ensure we have one row per process, and then we are computing processing time for each process by subtracting end time minus start time for each machine id and process id, and then we are calculating the average of processing time up to 3 decimals, and then we are grouping the average processing time by machine id, and let's see if it works for us or not. Okay, there is some problem, I think. Just let me check. Okay, the problem is that here I have written the instead of then, and other than that I don't think there should be any problem. Now let me check it again. As we can see here that our solution has been accepted, and test case is working as fine as it should. And now let's see the performance of this code. As we can see here that it has been all the test cases have been passed, and it beats 94.37% of users with the SQL. And that's it for the day 9 of this series. And if we want to do the time complexity of time complexity analysis of this solution, so here the step 1 is extract start and end times. So it takes o of n time complexity, since we are scanning the activity table once, and then we are doing the compute processing time, that is also o of n. That since we are computing the difference for each process, and then again we are computing average processing time. Here it is o of m, where m is the number of unique machines, and the total complexity is on, making it since that it is efficient for large data sets. So this solution ensures that we correctly compute the average process completion time for each machine while keeping the performance optimal, that is a big O of n. And let me know in the comments if you have got better solutions for this problem, or you have any problem or any suggestions to improve my video quality, then please do not forget to comment your views on it. And thank you for watching the video, and please do not forget to subscribe my channel and like the video, and turn on the bell icon so that you don't miss the upcoming videos in this series. Thanks for watching.